Hello, welcome back. We're going to continue our discussion from part 3 of Volume of Revolution. So let's take a look at another example here, number 4. We want to find the volume of revolution generated by revolving the region of this circle in the first quadrant about the x-axis. So that's nice. So we're already in terms of x, so that's all it means. We have to be in terms of x. Therefore, we're looking at a vertical rectangle of mathematics. So let's go ahead and sketch this. Now we know we're only interested in the first quadrant. And in our circle here, remember this is just our semicircle, we know that the radius here has to be 3. So it goes from 3 to 3, and it's just going to look something like this. So we're looking at our region underneath here, and when we revolve it about the x-axis, if I draw my rectangle of mathematics, man, I got to draw my rectangle in the region, the shaded region here. There's my rectangle of math. That rectangle of math is what gets revolved around the x-axis as well. And if you notice, we're going to form a disk, a vertical disk right here. That's what I'm looking at. To get the radius of our disk, well, that's easy to do. We just look at the top minus bottom because we are vertical. Same thing, always top minus bottom. So my top function is just going to be my circle. That's just the square root of 9 minus x squared. So we get the square root of 9 minus x squared minus whatever's on the bottom, which in this case is 0. Remember, the really short way to do it is think about the bottom is the axis of revolution. Whatever the axis of revolution is, that's your bottom function. So if we simplify this, we get the square root of 9 minus x squared, and now we're going to get the height. But remember, the height is just going to be dx this time because we're in terms of x. There. So I write it out. Volume, we're using pi r squared h. Plugging it in, we get pi. If I square the 9 minus x squared, the square root of that, dx, we're just going to get pi times 9 minus x squared dx. Remember, height is just the dx right there. And we're going to evaluate that. Well, we're in the first quadrant, so my bounds go from 0 to 3. That's it. 0 to 3. We're starting at x equals 0, we're ending at 3. All right, so we just keep going, solve this one, not too bad to do. We're just going to give it pi times, not pi equals, pi times. Let's see what we get. That's just 9x minus x cubed over 3 from 0 to 3. Now, if you notice, I always put my pi on the outside. It's just a constant, so I can just leave it to the outside. We've done those in previous videos. You can take a look back at those. So our volume is pi. Plugging in the 3, we get 27 minus 3 cubed is 27 over 3 minus, now we're going to plug in the 0, that's easy, 0 minus 0. So if one cleaned up, it's just pi times 27 minus 27 thirds. There's your answer. Very easy to do. These are pretty easy. Cakewalk, cakewalk. All right, woohoo, let's take a look at a Triggerlicious function. All right, here we go. We're going to rotate the following region, enclosed by sine equals 1/2, the y equals 1, sine of x to the 1/2 on the domain 0 to pi. We're going to rotate this about the x-axis, which is nice. It just tells us we're going to be in terms of x. We like that, in terms of x. Determine the volume formed. So notice, if you notice here, we already drew our rectangle of math. When we revolve our rectangle of math around the x-axis, we're going to get a disk. And I can just draw that disk out. That's really what I want, what I really, really want. The radius of my disk is just the height of my rectangle. Top minus bottom. See, this forms a circle right here. I just want the radius. The rectangle of mathematics is our radius. So that's going to be the top function, which is just the sine of x to the 1/2 minus the bottom, which is just the x-axis, so that's just 0, so minus 0. So we just get sine of x to the 1/2. Our volume, pi r squared h, and we just plug it in. Pi, be careful, the sine of x to the 1/2 squared, don't forget dx this time. My dx is just the height, right? My height is just dx, always dx. And if I simplify that, we just get sine of x dx. And now we're going to integrate that. Remember, this right here is the volume of one cone, the volume of only one, of one cylinder. I can't spell cylinder, so I'll use the word disk. That's the volume of one disk. This is the volume of all the disks. That's what an integral does. It just adds up an infinite number of whatever we want to add. All right, so now we can evaluate this from 0 to pi because they told us the domains above. And I just solve it. Volume equals pi, the antiderivative sign. What's that? Negative cosine of x from 0 to pi, which is going to become pi. Cosine of pi is -1, so we get negative of a -1 minus plug in 0, and cosine of 0 is -1, so we get +1 there. And let's see here, what do we get? Oh yeah, look, 2 pi, my favorite mathematical wrapper. Very easy to do. All right, so I want you guys to try a couple here. Try a couple, 6, 7, and 8. 6, number 6, right here. And I'm going to go ahead and work these as well. We want to rotate the region enclosed by the parabola y equals x squared on the interval 0 to 2 about the x-axis. So again, this is going to be in terms of x, right here. So in other words, therefore, it's going to be vertical for us. Determine the volume of the solid formed. So now we want to determine the volume. So if I sketch it out, there is my parabola. The region x equals 0 to x equals 2. There it is. So I'm going to shade my region. Shade. And revolve it about the x-axis. How revolting. Drawing my axis of drawing my radius is my rectangle of math. There it is. There's my radius. There's my radius. Whoop, I drew an arrow there. Sorry about that. Let me see. How do I get rid of that? Undo. There we go. I just draw my rectangle of mathematics. There is my rectangle, which is my radius. So if I revolve that about the x-axis, I get a disk. And that's what I want. How do I find the radius of that disk? Well, we're in terms of x, so it's going to be top minus bottom. Our top, again, is the parabola x squared, and the bottom is just 0, which is the x-axis. So my radius is just x squared. There's my height, it's just dx. So my volume, using my formula, pi r squared h, we would get pi, the radius x squared dx. Now remember, this is only for one integral, for one disk, I mean. So this becomes x to the 4th dx, and would evaluate that, and they give me the domain 0 to 2. So now this is going to find the area for the volume for all of my disks. In other words, it's going to actually calculate the actual volume of my region here when we revolve it. Now, we talked about this yesterday, but what we're really doing is what the domain tells us is that we are going to move this disk between 0 and 2. So the disk is going to move on the domain 0 to 2, and as it does it, it's going to fill in the area. Therefore, it's going to fill in a volume, not an area in this case. It's going to fill in a volume. Integrating pi x to the 5th over 5 from 0 to 2, and I can just plug this in, pi, plug in the 2, 2 to the 5th over 5, we'll deal with that later, minus just 0, so that's just 32 over 5, right there, times that. Piece of cake, easy as pie. All right, let's take a look, number 7. Go and try this one real quick, if you want to pause it. We are looking to find the volume enclosed by the line y equals 1/2 of x minus 1 on the interval, and y equals 0 to 2 and x equals 0. But this time we're going about the y-axis, so you gotta be careful. We have to be in terms of y. Determine the volume. So they give us the box here. Now the other reason you want to really do this one in terms of y is I could do this in terms of x, but it's really nasty. It's going to be right here, like here. This one's pretty easy. There's one rectangle. But once I get to this part, I have to do a new integral. Where they meet, I'd have to do 2 integrals if I did it vertical. So that's why we're going to choose to do this one horizontally. It's a little bit of algebra, but it's easier mathematically. So I'm going to draw my horizontal rectangle. There it is. And I'm going to revolve that rectangle about the y-axis. There's my rectangle of math. And if I draw this disk, it's going to be horizontal. So this time my height is going to be dy, the thickness of it. My radius, this is the tricky part, has to be in terms of y. So I have to do some algebra. 1/2 x minus 1. Solve it. I can solve for x. I get y plus 1 equals 1/2 x. So x is 2y plus 2. So we're going to do the right minus left. On the right, we have our line, which is what we have here. That's going to be this 2y plus 2. And on the left, it's the y-axis, which is our x equals 0. So minus 0. And we just get 2y plus 2. So let's just set this one up here. Volume pi r squared h, 2y plus 2 squared dy, and I am going to evaluate this, and they tell me to go from y is 0 to y is 2. So that's what I'm going to plug in right there. Solving this one, let's see here, I can expand it. This just becomes 4y squared plus 8y plus 4 dy. And we're not looking for pretty, we're just looking for an answer. Let me do this again, sorry about that. That becomes 4/3 y cubed plus 4y squared plus 4y from 0 to 2. And then just apply the FTC. Don't forget the pi. People always forget the pi, and that's the only thing that they miss. The AP will take off a point if you forget the pi. But they give you a point if you have it, so might as well have it. We have 4/3, y2 cubed is 8, plus 4 times 4 plus 8. Plug in the 0, 0 plus 0 plus 0. We like zeros in here. Not on homeworks, but in math, we like zeros. And if we want to clean this up a little bit, that's what, 32 over 3 plus 16 plus 8 pi. And there's your answer. Don't worry about making it nice. I actually make the 8 look a little bit nicer. That looked awful. There we go. A nice looking 8 right now. Don't clean that up anymore. All right, last one here. Oh no, revolve the region all about this parabola. Y equals 4x squared. Now again, we're going to rotate about the y-axis, which means we have to be horizontal and in terms of y in the first quadrant. So here's the graph right here. There's the graph. There's our y equals 4 minus x squared right here. In terms of y, that's easy. In terms of x, I can solve it. X would equal the square root of 4 minus y right there. So that's when we use my array. So when I look at my axis of revolution, because we want to make it horizontal, so there's my axis of revolution is the y-axis. There's my rectangle of math. And when I revolve it, you can actually kind of see the shape here. It's going to be kind of like a basket, really, an upside-down basket right there, or a gumdrop if you're hungry. So my disk this time is going to be sideways because everything's in terms of y, just like number 7. My radius, again, we're going to do the right minus the left. So the right function is our square root of 4 minus y. And the left, be careful, we're measuring to the y-axis. That's my rectangle of mathematics. We measure to the y-axis, which is just going to be 0, and we get square root of 4 minus y. My volume, pi r squared h. And let's see here. Pi, my radius, the square root of 4 minus y squared, dy this time. And I'm going to clean that up a little bit. That's just 4 minus y dy. And now I got to get my bounds. So to get the bounds, not too bad to do. We're in terms of y. Y starts at the bottom at 0, because remember we're only in the first quadrant, and it crosses the y-axis at 4. So y is going to go from 0 to 4 here. And just evaluate that. Pi, this becomes 4y minus y squared over 2 from 0 to 4. We get y, this becomes 16 minus 16 over 2. Don't know what that is. I'm just going to leave it. Minus 0, minus 0. Don't worry about the zeros. This is just 16 minus 16 over 2. There it is. If you're like, Mr. Warnow, I got to simplify it. It's just 16 pi over 2, if you want to simplify that. I hope you enjoyed the videos. Smash that like button. I'll see you later. Bye-bye.